When we're talking about rootkits, it's also important how rootkit actually gets installed in the system and how it's started inside the system as well. The simplest, of course, especially when talking about kernel rootkits, just to load the driver. Specifically on 32-bit operating systems, pretty much everyone was running as an admin. To drop the driver file on a disk and just load it would not be a big problem. However, of course, that would cause extra scrutiny by antivirus product because that's something quite easy to monitor. So the second option, and also the load of the driver, would be done by user mode process, meaning user mode process would be already running, and it means that while the rootkit is not loaded yet, but user mode process is running, the user mode process is not protected, right? It's not really protected by a rootkit. Means files are not hidden, processes not hidden, registry keys are not hidden. So that's not really optimal option. Most likely that would be an option if malware initiates infection and by some reason wants to have a rootkit capability without the reboot and without creating extra noise of the second option, which we're going to talk about in a second. They would do the load the driver directly. Another option is to create a service. That would be a Windows service with a type driver. And advantage of it that the service can be created with the different modes of auto start and the different priorities. So what rootkit would try to do is to set a highest priority in order and be loaded as soon as possible. In this way, when system gets rebooted, the rootkit has a chance, and what rootkit would try to do, to be loaded before antivirus product is loaded. So it can hide the malware before the antivirus product can actually scan and analyze malware. And the third most interesting option is actually file infection. Yes, it's exactly like viruses. The interesting thing is in 32-bit Windows operating system, they would not require a driver, a kernel driver, to be signed. And the only thing the Windows would actually check, if that's our MZP file as usual, right? And that's a legitimate driver. What it would have inside the header the CRC or control sum value, which would be computed over the whole file, excluding the value of CRC itself, and put into the header just to prevent an accidental corruption of the file. So that was not really a security feature, was never designed as a security feature. Instead, Microsoft designed it just to prevent accidental corruption of the drivers. But nevertheless, that was the feature. So if you would just modify a driver somehow, change a few bytes here or there, right, the CRC would not match and driver would not be loaded. So what malware would do is multiple options. It could actually work as a parasite virus and simply add legitimate driver, just override legitimate driver and add the legitimate driver as an overlay of the malicious driver. In this case, there is no deal with CRS332. Pretty much it's just a new file here, and here's the overlay. And when the malware is loaded, it would also load a benign driver. Of course, that would be quite easy to detect, right? There is, it's a change of the size of the file on the disk. It's pretty much a different driver, even though it has the same name. So the more advanced malware would actually infect the driver itself, the benign driver. So what they would do is they would change the entry point. So if that would be original entry point, the malware would change the entry point usually to resource section, because resource section is something that's not really needed at the start time. And the malware would implement its little loader right here, which will load another malicious driver or actual malicious driver over rootkit. After rootkit is loaded, of course, it would come back and fix those bytes to original bytes and then resume the execution of benign driver. In this way, the rootkit driver would not need to create it would not need to create a service. It would not do an explicit load of the driver. Instead, it would just need to infect existing driver and just wait until the system is rebooted, so this rootkit is loaded. Another advantage of this method is that malicious rootkit could infect NTOS kernel.exe. And in this case, the malicious code would execute even before any other drivers is loaded. It would be very important for rootkit to be loaded before antivirus solution. If the rootkit is loaded as a driver, it means it's competing with antivirus solution, and potentially antivirus will be loaded before and will detect the rootkit and remove it. By infecting the Windows kernel, rootkit guarantees that it will be loaded before antivirus solution and can hide all its components from it. It can also disrupt the antivirus solution load at all, and so antivirus solution is not loaded. In both cases, CR3 would need to be recalculated and fixed, otherwise neither kernel or driver will be loaded. Of course, none of that worked on 64-bit rootkits, because 64-bit rootkits would require any driver and kernel as well to be signed, and it would check the signature. Windows would check the signature before loading any of these modules, meaning if rootkit would infect any of them, just Windows loading or driver loading would fail because the signature check will fail. Thanks for listening. Don't forget to subscribe. See you in the next episode.